Let's get started with libraries. I've prepared two files, function putchar.c and function putstring.c. I'm sure you'll all know what these do. The syntax may be a little different, but I'm sure you'll understand how I did it. But that's not our main focus right now. I'll simply get back to creating a basic program. So, you know that if I wanted to write bonjour les gens, hello people, thanks to our function putstr, I should write a main that calls this function, and then compile. We agreed that if I only compile my main.c, the compiler is going to have a go at me and tell me, thanks for calling function putstr, but as I don't know where it is, I can't do what you're asking. So let's add function putstr.c, and now it tells me I can't find the function putchar you're calling in function putstr. So let's add function putchar.c, and now it should compile and display my bonjour les gens. I'm telling you all of this again because in order to create libraries, we'll first need to compile the functions you want to put in it. If I compile just my function putstr.c, it'll tell me that there still isn't a function putchar, but most importantly, we need a main in order to create an executable, as we've learned earlier on in the bootcamp. But I need to add my function putstr to my library, and I don't need my main. For that, GCC has an option, -c. Check out the man for more info. But look, it's created a .o. Function putstring.o. It's an object. It's computer language. As you can see, if you try to display it, it's nonsensical. Only a computer can read it. But in order to do anything, we'll need a main. As I said earlier, in order to create a library, we'll need .o files. Just imagine your program is a wall. And your .o file is a brick. A brick that's ready and that you'll be able to place in more than one wall, in the sense that once you've made your brick, you won't need to make it again. And each time, you'll be able to use it everywhere. That's actually quite practical. GCC knows about it. We could simply just use our .o like this, meaning I can create all of my .o object files and create my binary thanks to those. If I create this, it works very well. GCC successfully manages to create a binary for me. A binary that works. GCC can do anything. We can give it those famous bricks and it will know how to gather them and provide us with our a.out. We're not going to need a main, we just want a library, bracket lib. That contains both our function putstring, str, and function putchar. In order to do this, the first step is to create the .o files. Once we have the .o, we'll use with options R and C. I won't tell you what they do. You can search the man. Then after RC, we'll pass it our first argument, our library's name. For example, libstr.a. Why libstr.a? Because our library always starts by lib. I'll tell you why later on. So you add the name of your library, here str and .a, which is the extension for static libraries. There also exist dynamic libraries, but that's for another lesson. So, libstr.a as my library's name, then the files that contain the functions I want to add to this library. So the 2.o that I've just created, and with these info, AR does its job and displays libstr.a with both my functions in it. Now, how do we use it? As I've mentioned earlier on, I can take my main.c and tell it that the library I want to use actually is in the current directory by using the option -L followed by a dot. I can tell it to look for my library in this directory and tell it that the library's name it should look for libstr. Here you should only indicate lstr. That's how it works. And that's why the name of the library must start by lib. The -lstr will tell GCC that it's a libstr.a I need. Works the same as earlier when I compiled with my .c. The benefit is that now I can move my libstr.c anywhere. I could very well move it into my NFS directory and link it from there. This will allow you not to have to rewrite functions that you've known from the beginning. So that's one thing. You've seen that ARRC was enough to create my library. After a while, you'll realize that there are a number of functions which you'll create during this boot camp that may be worth putting in your lib. GCC successfully compiled with this command. But the day you'll have over 3,000 functions or even before, for example, when you'll need ft put str, which is halfway through your lib, you'll have to browse through your library in order to find ft underscore put string, str, and create your library. It won't use all of your library. To just use the function put str. It's a time-consuming operation, and when you'll manage to create more complicated programs and need to use libraries, and that will have to search through all of your libs to find the function in question, GCC will save its time because you'll have to browse through them all. For that, there's a program called ranlib. Ranlib simply takes your library as a parameter and creates an index in your library, which will allow GCC to know where to go. For example, it'll set function put char at position 1 and function put str at position 2, and so on. For all of the functions you may want to add to your library, it's extremely practical and optimizes compilation time. You'll see when you start collecting a great deal of functions, you should adopt this method ASAP. It'll prevent a great deal of bad surprises, and it always works the same. That's it for libraries.